Many of you, I'm sure, are aware of the limitations of MPLS, and you have either moved away from MPLS or are researching moving into SD-WAN or already have deployed that SD-WAN environment. But we know when MPLS was introduced, a couple decades ago, that it was really a good fit for growth and for private networks, especially given the centralized enterprise architecture. So typically, if customers wanted to access applications or users wanted to access applications, they'd ride across the MPLS network, they'd backhaul in the data center to access those resources. As cloud applications become more distributed and users become more distributed, we don't have data centers or regional access hubs to access these applications in each region. So this became challenging to manage when I want to add new locations, because I'm going to spend 30 to 60 days to add another service provider or another branch onto the platform. Also, as I'm working with carriers, it's very expensive to build out private connectivity to each one of the sites that sits on the platform to integrate into MPLS. And not only that, as large as the carriers are and many on-net buildings that they have, not every carrier is going to be on net to each one of the locations that you want to reach. So they're going to be procuring type 2 bandwidth from other providers. That's going to add to the process and add to the complexity underneath of the MPLS network. It's also challenging to add cloud providers directly onto the MPLS network, just as the same it is for branches. If I want to build a node in this region here on the left-hand side, I would have to procure private connectivity to get to the cloud provider edge with limited or no integration with the carrier. So again, if I want to add a cloud provider, it's going to be another 30 to 60 days for me just to integrate that into my MPLS network. So if we look at ways that customers are building out or transitioning to modernized network infrastructure to support similar predictability and performance that they expect for the MPLS network, there's a couple ways that they can do it now across the Megaport with MVE or modernized solutions that they can utilize. So as we work with customers, either they're still using MPLS or maybe they still have it as part of their infrastructure within their SD-WAN deployment. One of the biggest things that they enjoy around MPLS is that predictable performance from point A to point B. So one of the things that we hear a lot in the market today around modernizing the network or modernizing that underlying infrastructure for SD-WAN is a middle mile connection, where you're able to utilize the commodity DIA access at the branch, utilize a short hop over the internet, connect to a private backbone via the virtual edge, and then utilize along the longer path private connectivity. So what I gain here is I gain kind of the best of both worlds, where I can remove expense in setting up private connectivity to the branch, but I also only take a short hop across the internet. So I'm not relying on the internet end to end. I'm hopping on an SLA-backed backbone and building private connectivity back into the data center. So in Megaport's case, if you're connect to a Megaport-enabled data center, you can use the Megaport backbone for the majority of the length of that path. And this provides very similar performance that customers are seeing from traditional MPLS type of platforms. The other way that you can look at this is not just in backhaul to the data center, you can talk about building out your backbone. So maybe your global business, we have customers that are currently in Singapore, they've deployed MVE, they're aggregating these branch sites to the MVE. Then they're building private connectivity across the Megaport network, where they have another MVE that sits within the Bay Area in the United States. They're utilizing that longer path between these regions, very predictable, low latency, not having susceptibility to the internet on the longer path between those regions. And then they're utilizing the internet at each end on the short hop. So if we look at some of just the benefits of adding this MVE solution, we are global. So as your business grows, you're able to grow, with the solution. So if you want to deploy in additional regions as your business grows, you can certainly do that across the 13 countries, 48 locations. So you are getting that SLA backbone, short hop across the internet. So you're seeing very similar performance that you would from that traditional MPLS network from point A to point B. And then you have the flexibility to expand your network as you grow. So you're not locked into some long-term contract where you're paying for a 1 gig link or a 10 gig link. You're able to flex that capacity up and down as the business scales. Adding on to the backbone solution, the other challenge is typically around adding cloud connectivity to that MPLS network. So we know from some of the challenges of traditional network connectivity with MPLS, customers are backhauling that traffic into the data center to access their cloud providers, to access those applications. Now with a virtual edge and a modernized network type of solution, you can deploy these virtual data centers as these virtual hubs close to your users. And you can also then build on top of that backbone the private connectivity to your cloud resources. So if you want to access AWS, you can on-demand build connectivity to AWS. You can add GCP. Maybe you want to reach some SaaS applications within Salesforce. You can also integrate that into the service where you're building the private connectivity across the backbone and then adding that private connectivity within the region where you want your users to access those resources. So now from the branch, I'm taking this short hop over the internet and connecting to MVE. I'm using private access to access my cloud applications directly and keeping that all local. So lower latency, better performance. If we expand that and look at building on backbone connectivity between regions, you can mirror that situation in each one of those regions. So again, keeping that traffic local, short hop on the internet, utilizing the backbone to get between regions if I want to route branch to branch, but then also having my applications sitting closer to my users within that local region. So one of the benefits of Megaport's global network and the infrastructure that we've already built out is that when we look at these cloud providers, we have 230 plus on-ramps. So typically the edge of the cloud provider network is going to sit right where the Megaport MVE sits as well. So it's a very short hop once they get on the Megaport platform to reach those cloud services. You're eliminating the cost of paying for that MPLS backhaul to get between the regions to access those cloud resources. You're also then eliminating the cost of private connectivity to the branch. And you're able to scale not only this bandwidth up and down on the backbone, but you're able to add additional clouds. So as we see people moving into multi-cloud environments and consuming more as a service type of resources, you can add additional service providers when you need them as you need them and integrate that into your SD-WAN overlay. So one of the things that we're really excited about is the way that we can help manage a seamless transition from MPLS to SD-WAN, and also how you can utilize MPLS and SD-WAN together utilizing the Megaport platform. So if we look at the simple route of just one path, point A to point B from branch back into the data center, we're able to stand up in parallel another Megaport path or an as-a-service path where we're connecting those MVEs in two regions and also setting up private connectivity back into the data center. So this is really what we've seen as a great opportunity to take down a POC. You can then compare and see the similar performance across additional paths. So it's a great way to ease a transition from MPLS moving to a modernized network type of infrastructure. It's also a great way to have two different underlying paths where you still have, maybe you want some of that underlying MPLS for a couple locations in your network. You can also then build that secondary path where you're not relying on the internet all the way end to end, but you're relying on a short hop on the internet and getting similar performance on that secondary path. So if you're building out that redundancy in your MPLS network where you're taking down, two private links into each data center, you move to SD-WAN, you want to have that predictable security and performance across multiple paths, we can do that as well. The other piece of this is we do have customers that sit outside, or they want to keep their MPLS network that sits outside of their SD-WAN. So they're able to still maintain an SD-WAN, an MPLS network that can connect multiple sites, but then they can also build an SD-WAN network in conjunction. So finally, we have existing customers that we're working with that have legacy SD-WAN networks. They have a combination of the internet and MPLS as their underlay. So we've talked a little bit about some of the disadvantages of MPLS and the MPLS underlay. Now you add the internet on top. So if I look at branch locations where now instead of accessing applications and traditional MPLS back in the data center, I can divert route them directly over the internet to access the cloud. So I'm using internet from the branch all the way into the cloud. Not very good predictability and performance. The other piece of this is now I'm going to manage SD-WAN appliances that sit directly into the cloud. And then depending on my topology, I'm also going to have VPN tunnels between every endpoint that I want to route to. So you get quite a bit of a spider web mesh of IPN tunnels across the platform. If you look at the Megaport solution here, it's really bringing in the best of both worlds to where now I can still add branches quickly via the internet. I can then have short hops across the internet to a virtual data center or a virtual edge on the Megaport platform. I can build private connectivity into the cloud providers. So I can utilize that short path hop on the internet, private connection into the cloud. I can then bring those appliances out of the cloud, deploy that edge on the Megaport platform. I also get the benefit of the private connectivity and some cost reduction from the cloud providers in moving to a private connection. So when you move from the internet and you move to a private connection, you typically see a 60 to 70% decrease in the cloud egress costs or the data charges from the cloud providers. I'm also able to build a backbone on demand and adjust that backbone to on demand between each regions where my business is supported. I also can simplify the routing. So if I'm utilizing MPLS, I'm still having to manage that MPLS underlay. I no longer have to maintain that MPLS network. I also have a strategy now of adding remote users. So if you think back to that SASE scenario where network as a service and security as a service come together, via our vendors and their solutions, you can host SASE POPs on the Megaport MVE. So you can bring the edge of the network closer to your users, and you can use that zero trust network access solution to aggregate these remote users back into your network and bring the edge closer to those users. So overall, now we have a strategy to where we can tie in all the endpoints that want to access our WAN or access our network. We can build in the private connectivity between the long paths and the clouds. We can utilize the commodity internet to save cost in connecting to the branch versus private connections with MPLS, and bring that all in under one modernized infrastructure. So deploying faster, simplifying the deployment, and still seeing the performance and security that's required.